Welcome back. In this tutorial, we're going to cover Advanced Ortho number 6. So let's go through our normal drill. Do we have symmetry? Yes, we do. Left to right, front and back, and top and bottom are not the same, but the left half and the right half are the same. How would we describe this? I would say it's a kind of a block with some angled faces and a couple of holes in it, and an angled cut. Which view best shows the shape? You could say front view, side view. You've got some hidden geometry in here. So I would say front view. And where are we going to start? Well, let's go ahead and just start and draw this thing in the front view. So we know that we're 5 by 1 by 2. So let's go ahead and do it this way. We're going to do this a little bit differently. We'll sketch on the front, and because we have symmetry, we're going to project all 3 planes. And we said we have a 5-inch length, right? So let's go ahead and go 5, and we'll throw a symmetric constraint. This and this are symmetric about that. Drag our dimension down to kind of clean it up a little bit. And we're just going to draw in our shape. And it doesn't matter that things don't have dimensions. It doesn't matter that they line up. Because what we're going to do is we're going to show the power of the symmetric constraint. So we're going to go ahead and place a symmetric constraint. These 2 points between this line, escape out of that, go back in, and this are symmetric about that. Now that should make these 2 lines the same height. It should make these 2 points the same distance apart, and it should make those angles the same. So I believe this is 1 inch. And I believe we said this is 2. And let's go ahead and throw a dimension in here. I believe this is 1 inch. And let's see what we've got left over. So we know that this is 2. We are not given an explicit angle here, but since we know that this is 2, now we are fully constrained. We have 1.5 inches depth, so let's go ahead and extrude this to a depth of 1.5. Zoom out a little bit and look at our preview. And that looks really good. And so we've got 2 things really only left to do. The holes and this angled cut. Standard question is, which one is easier to do? The holes or the angled cut? I would say the holes are easy. So we know that this is a 1/2 inch inset and 3/4 inch from the front. So let's just go ahead, and there's 2 ways we can do this. We could put a hole in here and then mirror it over, or we could sketch on this face, finish. Let's back up a step. Let's project geometry. I got ahead of myself, I apologize. Project all 3 planes, and notice that our plane here for the XY is in the back. So really what I want to do is I want to make this extrusion symmetric. Now the part isn't necessarily symmetric, but this part of the part is symmetric. So hopefully that makes sense. And what we're going to do is we're going to go ahead and throw 2 points on here and here. Now the reason I made this symmetric and projected my geometry is this dimension now is always going to be in the middle. So if we know that that's going to be in the middle, then we can go ahead and do that. That dimension that we just put in was D7. D8 I'm going to set to equal D7 and hit enter. Now we can see we've got our little formula box there that says that these 2 are set to be equal. We can finish our sketch, put in a hole. I believe that diameter is 0.5. It auto-picked our 2 center points. Let's check. Yep, 1/2 inch drill. So the drill note, by the way, is just a note for manufacturing, how they would make it. Sometimes you've got a reamed hole or just a drilled hole, so it's how they make the hole, whether it needs to have a certain tolerance or precision. So that's done. So we're going to hit OK. And now, just like we did on incline ortho number 1, we need to sketch in the middle here. Unlike that one, though, we've got a plane which is our YZ plane here, so we can sketch on YZ. And if you remember, we made that wireframe so we could see inside to see our sketch geometry. I'm going to throw a point on here and a point up here. And actually that point, we're not going to need it. But that's okay. So we know that this point here has to be 0.5 up from the bottom. and then we're a 30-degree angle up to the top, which is good. So we're going to go ahead and we're going to draw our line from this point to this point. And let's just go ahead and put the triangle in real quick without any dimensions. We can add those. Dimension from the point to the bottom is 0.5. And then we know that this angle here is 30. And that's it. We're fully constrained. Finish sketch. Extrude that as a symmetric cut. If we were to not change this to cut, we should get an error message that says that it didn't change the number of faces. So we can edit this, make it a cut, and hit OK. Change back to shaded with edges, and there is our part. So when I say that we like to look at our parts and compare them to our PDF, if you look here, you can see this circle comes by and it stops right at that corner. And I've got the same thing right here. This circle stops right at that corner. So this looks good. Actually, it doesn't look good. This is too wide. Aha! Okay, so change that to 1 inch. And that fixes that. So a quick comparison between the PDF and the Inventor screen. Sometimes what you can do too is, especially if you're on Windows 10, you can snap this and you can snap that, and then you can kind of compare them side by side. I show you this now because I do not like it when you do it this way in the CAD. So I want you to either have those printed out, or if you're an LZ student, pull up your PDF on your iPad. You can get that off of Canvas. Or if you're a CLC student, you can get that. If you have another device you can look at the PDF with. It just really messes with the ribbon. And so I prefer that you stay full screen when you're working on those, unless you're just comparing, if you have to do it on one screen. Okay, that's going to conclude this tutorial. Thanks, and we'll see you in the next one.